So, Chapter 8, Calculus, Practice Test 2. It's the same, all of these sheets, and there's like 5 of them. They all have the same 7 tricks to start, but usually in a little different order. A lot of these are still in the same order as yesterday's, but not exactly, I don't think. But here we are. The trick for 1 is to pick a U. Make sure you find the DU, go at it. The answer is going to be the root that the problem had, and these all have a plus C. 2 is factoring by completing the square moment, and that creates an inverse trig problem. There's one of those on every packet. This one is inverse sine of a fraction, x minus 7 over 7. 3 is that the top has a higher power than the bottom, and even if they were an equal power to the bottom, you'd have to long divide that to make new pieces. Final answer on this is 3/2 x squared minus 2x plus 4 ln, and then x plus 2 in bars. 4's deal is to foil some stuff and know some trig tricks or have the trig tricks on your card. The integral you end up with here is negative sine squared. Sine squared is an integral that's on your card. So that's not always immediately an integral on your card, but in this case it was. It's negative x over 2 plus sine 2x over 4. 5, the trick is separate one fraction into 2. 4x owns one of the tops, the 6 owns the other top, the bottom stays the same in each one, and you go at it. Any fraction integral has to either be an ln, an inverse trig, or a pick a u, and there's only one pick a u on this page. We already did it. So this gets you an ln and an inverse trig. It's 2 ln, no bars, just parentheses around 1 plus x squared, plus a 6 inverse tan x, plus our good friend the c all the way down. Anybody need help first 5 guidance?
Number 3.
Number 3, did you long divide?
Yeah, but I think I got it wrong.
Did you get 3x minus 2 for the quotient?
3x. I got 3x.
Okay. Then when you do that cycle, you'd have an 8x subtracting a 12x to get a negative 4x for a second.
Yes.
Then
Oh,
2x
and then
into that.
divide again. I understand.
Okay.
So 3x minus 2.
Yes. And the remainder will be an 8.
Okay.
Is that enough?
Yeah, probably.
Okay. More to 5. 6, you're going to multiply by the bottom by a conjugate. This leads to some trig tricks, potentially including separating it into a couple fractions, which is what happens on this one. If you get to a point that it's the integral of secant squared plus secant tangent, you did nice trig work. And those are both on the card, so we're ready to pop an answer there. It's tan x plus secant x, still plus c's for this page. 7 is just straight off the card. If it didn't make it on the card yet, you didn't really do that when we were on 8.1. There was a couple things that made it on the card for that. This one's negative 1/8 ln, and then in bars cosecant 8x plus cotan 8x. 8 is integration by parts. The new integral you make is unfortunate because the top and bottom will both have x squareds, so you do have to long divide the new integral that's made. But grand total is a lot of pieces. It's 3/2 x squared inverse tan x minus 3/2 x plus 3/2 inverse tan x, and the plus c, as I said, is still alive. 9 is tabular integration, so is 10. It's x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6e to the x. 10 is 4t squared sine t plus 8t cosine t minus 8 sine t. If your signs are wrong, it could be because the trig makes you alternate signs, or it could be because tabular integration makes you alternate signs, and maybe you just messed up one of those deals. 11, this one made it exactly yesterday. It also makes it onto sheet 3. It also makes it onto sheet 4, so I would strongly guess that it would also make it onto the test. But this one's x ln x minus x plus c. Can I do anything for you?
Number 6.
So I multiplied the bottom by 1 plus sign.
Yeah.
So I have to do that on top. Top will just be 1 plus sign. Bottom will be 1 minus sine squared.
Yeah.
Change bottom to cosine squared.
Okay, so it'll be 1 over cosine squared
Which is secant squared.
plus sine over cosine squared.
Yeah. And sine over cosine is tan, and then that stray cosine makes a secant.
Okay, so it's secant squared plus tan plus secant.
Secant squared plus secant times tangent.
Okay.
And those are both on the card.
Okay.
More. 12 is the one that runs in a circle, and you end up with 2 of the problem eventually by combining like terms and have to divide by 2 to get the answer right. That's e to the x sine x plus e to the x cosine x, all on top of 2, plus a c, and then we take a break from the plus c for the rest of the page because we're not doing any more integrals till we get to the next page. 13, I just want the fractions. It's negative 2 on top of the x plus 4, adding a 3 on top of an x plus 3. 14 is a 4 on top of an a plus 4, plus a negative 5 that's on top of an x plus 4 that's squared. 15 is a 2 on top of an x, plus a 3 on top of an x plus 4. 16 is 3x plus 4 on top of x squared plus 2. Plus a 5 on top of an x plus 3. Anything there?
When you're doing like the ax squared plus b stuff, and like getting it to equal separate equations, did you go through those?
Yeah. So my letters will be only the same as if we made the same initial choices, though. So like your x squared plus 2 top, was it originally ax plus b?
Yeah.
And then your x plus 3 top, was it a c?
Yeah.
Then we're on the same page. So there's an a plus c to equal 8.
Yep.
There's a 3a plus b equal a 13.
Mm-hmm.
And there's a 3b plus 2c equal a 22.
Yeah, I got those.
Okay. Then you could go a lot of directions from there. I would use that AC equation to either kill the 3A and make a BC equation, or use that AC8 equation to kill the 2C, and that would make like an AB equation.
Okay.
And whichever way you do it, you'd either have 2 equations with AB only, or 2 equations with like BC only.
Okay.
And then you can play off of them from there, but it's hard to predict what those will look like.
Alright.
Does that strategy make sense?
Yeah.
So you have to do that process like twice.
Yeah.
So one to get it like, so that it's just like A or B's or
Yeah.
whatever, and then you have to do it again
Yeah.
to like find one of the numbers. Okay.
Yeah. Yeah, it's an unfortunate setup because you have an AC group, an AB group, and a BC group, and none of those are quite like the way you'd want it to
Yeah.
be, so you have to make 2 equations that either both have AB, both have BC, or both have AC. And I think it's easiest to use the AC8 thing as your like attack dog.
Yeah.
But if you kill an A, you'll get BC. If you kill the C, you'd get an AB. Either way, you're good. Your new creation will match pretty well with another one then. You know, it's not even bad if you used the 13 and 22 equations to play off of each other to kill like B's. You'd get an AC equation that way too that can be friends with the AC8. Like any of that can work. But yeah, it's going to take you like 3 plays. More to 16, anything? 17 to 19 page. I think the book pages of this were the hardest of the 4 lessons. I don't know that the sheet page of this is harder than the other lessons, but you do need an extensive amount of stuff written on your card to guide you through this. But 17, the substitution, before you can make the substitution, you have to divide under the root by 9, which means you have to divide the 12 by 3 and then go at some things. My substitution, x equaled 2 tan. And if you do a lot of nice substituting and canceling, the integral you're doing will be 4 integral of secant. So if you want to jot down that that's a goal, to get to a point that it's 4 integral of secant, that's a worthy spot to try to get to. Final answer will be 4 ln bars, 2 fractions adding a root of 4 plus x squared on top of a 2, adding an x on top of the 2. And if you want to make that together as a common denominator, like, hey, go ahead, but I don't care. 18 works a little better initially because you don't have to switch anything around with divisions. X would equal 2 secant. You go add it. The integral you get will be 1/8 integral cosine squared. So if you arrive at 1/8 integral cosine squared, you're in a good spot. If you never did, then I can try to help you get there. Final answer is going to be some kind of an inverse trig thing that you can make any choice you want. I chose 1/16 inverse cosine 2 over x because that's the choice where I don't have to write a root in my fraction, but others would be fine. Plus the root that we started with on top of 8x squared. 19, I got x equals 4 sine. I got to a point where I had the integral of cotan squared, which is good, but not on the card. And then I did one of those like squared 1 trig plays to change that around. Final answer, I got the original, close to the original problem, negative that original fraction just with an x on the bottom, minus an inverse trig thing that you could pick anything. I picked inverse sine and did x over 4. Can I help you with something on those? That might be still the hardest page even of this. I might reconsider my earlier comments when I said I don't know that that page is harder than the other ones. I kind of think
17.
it's 17, were you with the idea of bottom has to divide by 9,
Yeah.
so top had to divide by 3?
Yeah.
Okay. Then since it's the adding substitution, that's x equal 2 tan theta.
Yeah.
So dx equals 2 secant squared theta.
Dx equals what?
2 secant squared theta.
Okay.
You with that?
Yeah.
Okay. So then the top will have the 4 where the 12 used to sit, a 2 secant squared. The bottom, because of what
Wait, why is it a 4?
the
Oh wait, because you divide. Okay.
You okay?
Because you divide the 3 by it, so
Correct.
that's now a 4.
Yeah.
But then, wouldn't that be an 8?
It'll be
Because
an
there's Okay.
I just kind of write all my pieces and then cancel pieces
Okay.
and then put stuff together. But yeah, there's a 4 about, there's a 2 secant squared about. The bottom, the card will say that under the root, you'll get a 4 secant squared. So if you're ditching the root, the bottom will be 2 secant.
Okay.
And then just cancel a bunch of stuff. So with the numbers, you're going to be left with a 4 that you might as well like plink out to the before the
So it's
problem.
4 secant.
And the integral you're doing is secant.
Okay.
The integral of secant is on the card. It's ln bars
Yeah.
adding stuff. And then you're going to use now you're finally going to use the triangle that we drew. You need guidance through the triangle drawing.
I don't think so.
Okay.
That's like the one part of this that I've understood.
Okay. And then we're going to that triangle to just like play Oscar having a heap of apples
Yeah.
to himself. Rewind anything? Is that enough?
Would that root be 36 plus 9x squared? Or-
No, it'll be a 4 plus x squared.
So it's after the divided
Yeah.
stuff? Okay.
Mhm.
Okay. And then. What was the answer to that again?
4 ln bars, root 4 plus x squared on top of 2
Yeah.
plus x over 2.
Okay.
Other people, other stuff on that
Is that
page?
x over 2 in the bars?
Yes. Yeah, because the card said to have ln and then in the bar secant plus tan, so. So we wanted.
Oh, okay. Okay.
18, 19, more stuff. And it's kind of nice when you turn the page, I think, I hope. Which setup was the first one?
96?
96. X, inverse sine 4x plus 1/4 root 1 minus 16x squared with a lot of plus c's. 21 is 76. It's 1/3 tan 3x over 2. 20, I was a little bit mean because it doesn't initially fit a setup perfectly, so you have to perform an algebra maneuver to make it work. Under the root, did anybody have a thought?
Divide by 25.
Divide by 25, so on top,
It's just a 1.
it would
But
be
you
a
divide
1.
by 5.
Divide by 5 and it'll be a 1. Then it's there. Anybody see it? It is 20. And 20, you have a choice between a shorter answer that you have no idea what it means, or a longer answer with ln in it, right? Does it give you an either or? Because I have 2 answers on mine. It's an either or. Does the table give you an either or on 20?
Yeah.
Okay, so there's something called there's hyperbolic trig, which we didn't do at all. So if you go and take calc in college and they do hyperbolic trig stuff, like, you didn't forget that. We just didn't encounter that in the parts of the book we did. But it's inverse hyperbolic sine of x over 2. Or you could do ln and then in parentheses x plus root 4 plus x squared plus c. 23 starts with number
87.
87, which will later lead you into number 85. Grand total is negative cotan cubed 6x on top of 18 plus 1/6 cotan 6x plus x plus a c. 24's number. 55 is correct. Negative a fifth root fraction under the root that has 10 minus x on the top and then an x on the bottom. Can I do anything more for you?